So today we are going to solve our systems using the elimination method, okay? It's going to be the same thing we did last time. We want to find what? When we're solving a system, what are we looking for? You have your two lines, what do we look for? Where they intersect, where the two lines meet, touch, cross, intersect, okay? Last class, we did it by graphing, okay? Just really quick, noticing, are these equations ready to be graphed? Are they in y equals mx plus b? No, they're not. That's why today we're not going to solve these by graphing. If your equations are in slope-intercept form, y equals mx plus b, I strongly suggest you solve by graphing. If they are not, I would not necessarily solve by graphing because some of us struggle solving for y. So that's why we're going to learn our elimination method. When we are doing elimination, the coefficients of one of the variables must be opposite of each other. So that means that your two x's, one needs to be like a 3x, and then the other would be a negative 3x. Same coefficient, but opposite signs. Okay? If they are not, you must multiply one of the equations by a number to make them opposites. Okay? When are we going to use this method? We are going to use when both equations are in standard form. Just like our unit over solving quadratics, I could use elimination anytime I want. Okay, for any system, I could use elimination. But in order to use elimination, you have to first get it in standard form. So I would only use elimination when they already are in standard form. What's our standard form? AX plus BY equals C. Okay, the X and the Y terms are on the left. Your constant is on the right. The variables are together on one side, the constant is on the other side. Okay, you want both equations to be in standard form. Good? So let's look at number 1. Again, also like last unit, just because it says solve by elimination, you wouldn't have to. If you want to solve these for y and graph them, you could do that. Okay? Looking here. First thing we're going to do, are they both in standard form? X, Y equals a number. X, Y equals a number. Are they both in standard form? Yes. Also notice, are my X's stacked on top of each other? Are my Y's stacked on top of each other? Are my equals stacked on top of each other? And are my constants stacked on top of each other? That's how you know this is set up perfectly for elimination. Okay? So it's set up for elimination. Now we need to see if one of the coefficients, if the coefficients of one of the variables are opposites of each other. My X coefficient is 5. This X coefficient is 3. Are those the same numbers? No. No. Okay. What's my Y coefficient? Negative 1. What's this Y coefficient? Positive 1. So are they the same numbers? 1 and 1? Yes. And are they opposite signs? Yes. So we don't have to multiply by anything. This is already set up perfectly for elimination. Okay? So what we're going to do is we're going to draw a line under this, and we are going to add vertically. Add your like terms. Add the x's, add the y's, drop down your equals, add the constants. What's 5 plus 3? 8. So 8x. What's negative y plus y? Why do you think this is called elimination, guys? One of the variables will always be eliminated. Okay, that's why it's called elimination. One of your variables will always be eliminated. Drop down your equal sign, and then 12 plus 4. The reason I'm adding the 4 is because 4 is positive. If 4 was negative, I would do 2 minus 4. But since it's positive, 12 plus 4 is 16. Do we know how to solve equations that only have one variable? Yeah, this equation now only has one variable. We're ready to solve it for x. What am I going to do to get x by itself? Divide both sides by 8. And I get x equals 2. We are not done, because we know a solution to a system is a point that's just the x value. Now that I know the x, what do I want to find? The y value. Okay? Now, if this ordered pair that we get as our solution is on both lines, does it matter which equation I choose to substitute the 2 back into? No, we will get the same y value. So it's just personal preference. I don't really want to deal with the negative, so I would rather deal with the 3x plus y. Okay? So I'm going to do 3, not x. What's my x value we just calculated? 2 plus y equals 4. 3 times 2 is 6, so 6 plus y equals 4. And how do I get the y alone? Minus 6 on both sides. And we get y equals -2. Did I find my x value? Did I find my y value? Yes. Here is my solution. How do I write it though? How do we write solutions, guys? As an ordered pair, x comma y, so 2, -2. What happens if that ordered pair? My 2 lines intersect. Can you check yourself? Yeah, let's make sure this point is also on my top equation. What's 5 times 2? 10. What's a -2? Because y is -2. So what's a -2? So 10 plus 2 is 12. It worked. Okay? What's 3 times 2? 6 plus a -2. So what's 6 minus 2? Did that work? So I plugged these back into both equations, and both of them gave me a true statement. That means my solution is correct. This point is on both lines, meaning that is where they intersect. Good? I will tell you, sometimes, guys, elimination is like really, really easy. This wasn't that bad. It was already perfectly set up for elimination. We didn't have to do anything to it, to manipulate it, to get it into the correct form to eliminate. Okay? Sometimes they will be that easy. Okay? Do you think they're always going to be that easy? No. Okay, let's look at number 2. Are we set up in the form C, D equals a number, C, D equals a number? If you remember from last class, we didn't just use the variables x and y when we did our word problems. That's why I changed it up. We're not just doing x and y. Okay, we have C and D. C could maybe mean cats, D could be dogs. Okay? So now we need to see, so they're already stacked on each other, so that means that we're going to do elimination. Now we need to see if I have coefficients that are the same number and opposite signs. So do my C coefficients have the same number? Yes. Are they opposite signs? No. Do my D coefficients have the same do my D variables have the same coefficient? 7 and 2? No. Okay, so I definitely am not going to want to get rid of the D's. But 6 and 6, those are the same, so that meets one of the 2 requirements. The other requirement is their opposite signs. Okay? So what can I do to this 6 to make it a negative? Multiply the whole equation by a negative. The only thing I needed to change was to change the sign. Okay, so I'm going to put a negative. Our phones are away, right? Okay, so I'm multiplying the whole equation by a negative. So this becomes negative 6c minus 7d equals positive 15. Are we good with that? I'm not going to change my second equation, so I'm just going to drop my second equation below the one that I did just change. Before you eliminate, make sure that one of the variables will actually eliminate. Do my c's now have the same coefficient? Are they opposite signs? So they now will eliminate, okay? So what's negative 6c plus 6c? They eliminate. They cancel out. What's negative 7d minus 2d? Negative 9d. Very good. What's 15 plus 12? 27. Again, after doing your elimination step, one of the variables should be eliminated. You are left with an equation that only has one variable. How do I get the d by itself? Divide by negative 9, and I get d equals negative 3. So that's only one of the two values of my solution. I now need to find the c value. Whenever you're substituting this back in to find the other variable's value, always use one of the original equations. Don't use this one that I changed, okay? Always use one of the original equations to find the next variable. Which one do y'all want to use? Top equation, bottom equation. Remember, I said personal preference doesn't matter. They both should give you the same answer. Top or bottom? Top, okay? So I'm going to do 6c plus 7. What did I just calculate d to be? Negative 3 equals negative 15. So 6c, what's 7 times negative 3? Negative 21. What do I do next to find the value of c? Add 21. And I get 6c equals 6. What do we do next? Divide both sides by 6, and we get c equals 1. Do I now have both variables' values? Which order do you think I should write it in? CD, DC? CD, go in alphabetical order. Okay, so 1, negative 3. Guys, are these obviously a little bit more work than we did last time with just graphing? Yeah, you have to do a little bit more math work, okay? But do you see why this might be easier solving two equations for y then graphing? Okay, again, some of us struggle solving for y, so if they are stacked on top of each other, if both equations are in standard form, I would use elimination, okay? Again, just like last unit, you could solve them both for y, graph it, and find the intersection. That would work as well. And you should get the same answer, okay? Ready for the next one? Okay, are my variables stacked on top of each other? Are they both in standard form? X, y equals a number, x, y equals a number. Yes, so it is set up for elimination, so that's how I'm going to solve it. Now look at your coefficients. X has a coefficient of 2, and x has a coefficient of 1. Those aren't the same numbers. Y has a coefficient of negative 3, and a coefficient of 4. Not the same numbers. Wah, wah. This makes it a little bit harder, because I don't, like in the last one, all I had to do was change the sign. If I change the sign, the variable's coefficients still are not the same number, okay? So we're going to have to multiply not just by a negative, we're going to have to multiply by a number, okay? You get to choose. It doesn't matter if you get rid of the x or the y first, okay? Normally there's an easier one though. So you want to think of the least common multiple, okay? So Like multiples of 2 would be 2, 4, 6, 8, 10, 12. Okay, something that multiplies. And then what are multiples of 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's your least common multiple of 2 and 1? 2. Well, is this one already 2? Yeah. So do you see why it would be a good idea to get rid of the x's first? This one already has a coefficient that's the least common multiple. So I won't have to multiply this equation by anything. If it's a 1, what would I multiply it by to make it a 2? 2. So I'm going to multiply this whole equation, the bottom one, by 2. Now, if I multiply it by a 2, they both have a coefficient of 2. I don't want them to both have a coefficient of 2. I want one to be a 2, and I want one to be a negative 2. So instead of multiplying by 2, I'm going to multiply by negative 2. Okay, are we good with that? I'm going to rewrite my top equation over here just because I want them to be stacked on top of each other. But I didn't change it, so I just rewrote it exactly as is. Now the second equation, I'm going to multiply or distribute that negative 2. Negative 2 times x, negative 2x. Negative 2 times 4y, negative 8y. Negative 2 times negative 9, positive 18. Do I now have variables with the same coefficient but opposite signs? Yes. My x's have the same coefficient of 2. One's positive, one's negative, so it's ready to eliminate. What's 2x's minus 2x's? Put your phone away, it shouldn't be in your lap. Negative 3y minus 8y. Negative 11y, very good. What's 4 plus 18? 22. Again, how do I know I'm adding them? They're both positive. Okay? Now I need y by itself. What do I do? Divide both sides by negative 11. So I get y equals negative 2. Thank you. Okay, so I found y. Which equation do y'all want to use to find x? Again, it doesn't matter. Personal preference, top or bottom. I would use the bottom because it will be easy when the x doesn't have a coefficient. So x plus 4 times y is negative 2 equals negative 9. So x, what's 4 times negative 2? Negative 8 equals negative 9. What do I do next? Add 8. So I get x equals negative 1. Do I have my x value and my y value now? Here's x, here's y. Negative 1, negative 2. Make sure you write it in the correct order. Even though I found y first, I'm not going to write negative 2 comma negative 1 because I know ordered pairs are always x, y. Okay? So it doesn't matter which variable you find first, make sure your ordered pair, your solution, is written in x, y. And in the last one we had c and d, put it in alphabetical order. Good? How are we feeling after doing 3 of these, guys? Like, okay, bad. It's okay to say you feel bad. It's okay to say you feel Okay. I obviously like the graphing better than this. I think that was easier. Okay. Some of these, like I said, are easier than others though. Like that last one we just did was the hardest we've done so far. Okay. Looking at number 4, are both equations in standard form? Are the variables stacked on top of each other? Yes, so it's set up for elimination. So now you look at your variables' coefficients. Negative 3, negative 2. Are those the same numbers? Nope, skip our x's. Look at your y coefficients. Negative 4, negative 4. Are those the same? Yes. Are they opposite signs? No. So I need to multiply one of my equations by a negative to make them opposite signs. Does it matter which one I multiply by a negative? No. Which one do y'all want to multiply, top or bottom? Top. Sounds good. Biggest mistakes here, guys, is people forget to multiply every term by the negative. So draw your distribution arrows. Like I've been saying all year, when we distribute, draw the distribution arrows. That negative has to go to the right side as well to make that negative 18 positive 18. And then I'm just going to rewrite my bottom equation below it so they are lined up. What would happen if while I'm working this, I add these two terms, get a value, add these two terms, get a value, still had an x and a y? You did it wrong. When you're doing this elimination process, when you combine the two equations to make one equation, you will only ever be left with one variable if you did it correctly. Okay? If you have both variables still left, you did something wrong. Okay? So what's 3x's minus 2x's? 1x, which is also just x. What's 4y minus 4y? Gone. Equals, what's 18 minus 8? That one seemed pretty easy, right? X is all alone. We're done solving for x. X doesn't have a coefficient, so we don't have to keep going. Now we need to find our y. Would y'all rather use the top or the bottom? Both of them have lots of negatives, so I wouldn't really have a personal preference. Which one do y'all want to use? Bottom, I heard. I would maybe use the bottom just because they have smaller numbers. But again, we would get the same answer if you chose the top. So negative 2 times x, which we just found to be 10, minus 4y equals negative 8. Negative 2 times 10 is negative 20 minus 4y equals negative 8. What do I do to get the negative 20 away? Add 20. Sierra, do we have a jacket? Put one on, okay? Thank you. What's negative 8? Where are you going? Put it on. Put your jacket on. Okay, get it. Negative 8 plus 20. Positive 12, very good. And then what do I do next? Divide by negative 4. And I get y equals negative 3. So I have my x and my y. How am I going to write my answer? 10, negative 3. You doing good? I will tell you guys the next two are going to go super fast. Okay? And then we're going to do our 2-word problems, and then we're done for today. And you'll have plenty of time to do your homework. Okay, number 5. Are my variables stacked on top of each other? Are they both in standard form? Yep. X, y equals a constant, x, y equals a constant. Do my x's have the same coefficient? Yes. And are they opposite signs? Yes. Positive 2, negative 2. That's the same number. They're both 2. One's positive, one's negative. So I have to do nothing. This is already perfectly set up for elimination. Okay? Draw your line under it. What's 2x minus 2x? 0 x's. They eliminate. What's 3y minus 3y? 0. It eliminates. So is there anything left on the left side of this equation? You can't leave part of an equation blank though, so what do you think we should put there? 0. There's not an x. There's nothing left. So a 0 represents nothing being left. Drop down your equals. What's 4 minus 4? So again, when we are solving, our goal is to find the value of the variables. Do I have a variable? So we're done. Okay? Is this a true statement or a false statement? This is true. So if this is true, remembering from last class, what do we think our solution is? Infinitely many solutions. So let's write a little note to ourselves. All variables cancel, and you have a true statement. That means infinitely many solutions. So if all your variables cancel, you know you have a special case because you have no variables left. You can't find values of variables if there are no variables. So if all the variables cancel, then it's a special case. Your two options are no solution or infinitely many solutions. A true statement means infinitely many. Good? Ready for the last one of these? What do we think this next one's going to be? Not true, so probably. What's the opposite of infinitely many? No solution. Let's see that. Are we both in standard form? X, y equals a number. X, y equals a number. Yep, so they're both in standard form. It's set up for elimination. Do my x's have the same coefficient? They're both 6's. And are they opposite signs? Yes. So do I have to change either equation? No, they'll already eliminate. What's negative 6x plus 6x? No x's. What's 2y's minus 2y's? No y's, so 0 equals, what's 5 plus 4? 9. Does 5 equal, does 0 equal 9, guys? No. That is wrong. Making this no solution. So we're going to write a little note to ourselves. All variables cancel. Then we have a false statement. This means no solution. Good? Okay, let's look at number 7. Now we have our word problems. So this is putting together what we did last class. Last class we read a word problem and we wrote 2 equations. We identified our variables and wrote 2 equations. Today we're solving using elimination. So these word problems are going to put both of those together. We're going to first identify our variables, write our 2 equations, then solve using elimination. Okay? So it says 3 apples and 4 bananas cost $4.85. 3 apples and 10 bananas cost $8.75. So what are my 2 unknowns here, guys? So A is apple cost and B is banana cost. You, sir, are we sitting up, sweetie? Okay, so I bought 3 apples, so that would be what? 3A. Then I also bought 4 bananas. I just put 4B plus 4B because you bought more stuff, so your cost went up for a total of $4.85. Then 3 apples and 10 bananas cost $8.75. 3A plus 10B equals, very good. So do you see why this is set up for elimination? My A's are stacked on top of each other, my B's are stacked on top of each other, my equals are stacked on top of each other, and my constants are stacked on top of each other. Okay? So now we're going to look and see if our variables have the same coefficients. I have my A coefficient being 3 and my A coefficient being 3. Are those the same? Are they opposite signs though? No, so what do I need to do? Multiply by a negative. Doesn't matter which one. Now I'm just going to do my top. Okay. Distribute the negative, so negative 3A, negative 4B, and negative 4.85. So now I'm going to combine those two equations. What's 3A minus 3A? No A's. What's 10B minus 4B's? 6B's. What's 875 minus 485? We have calculators. What is 875 minus 485? Wrong way. 390. Okay, what do I do to get B by itself? Divide by 6. So my B is but what does it equal? What's that? What's 390 divided by 6? Yes, ma'am. 10 minus 4. .65. Which equation do y'all want to use to find A? Top or bottom? Top, sounds good. So 3A plus 4, not B, but 0.65 equals 485. Use track, come on. So 3A, what's 4 times 0.65? 2.6 equals 485. What do I do next? And we get 3A equals and then what do I do next? And we get A equals so here is my answer. Do you think I'm going to write this as an ordered pair, guys? If now these variables mean something, do you think I'm going to write it as an ordered pair? Or do you think I'm going to use words since it's a word problem? I'm going to use words. So I'm going to say apples cost 75 cents. And bananas cost 65 cents. Do you see why it's beneficial to use variables in your word problems that represent something? Okay, when I see A equals, it's clear that that's your apple cost. When I get B equals, that's clear that that's your banana cost. Good? Ready for our last one, guys? Yay. Okay, Reagan School selling tickets to a spring musical. On the first day of ticket sales, the school sold 3 child tickets and 9 adult tickets for a total of $75. The school took in $67 on the second day by selling 8 child tickets and 5 adult tickets. The spring musical must not be very good because not a lot of people are going. So what are my unknowns? Adult ticket cost and child ticket cost. Okay, so I'm going to say A is adult cost, and C is child cost. On the first day, they sold 3 adult, sorry, I can't read today. On the first day, they sold 3 child tickets. So how would I write that? 3C, very good. And then they also sold 9 adult tickets. A for adults. For a total of how much money? Okay, on the second day, they sold 8 child tickets. How are you going to write that? We doing this with me, Morgan? And how many adult tickets? For a total of $67. Okay, this one is going to be the hardest one we've done because you're going to have to multiply both equations, and let's talk about why. It is stacked on top of each other, C's on top of C, A's on top of A, equals on top of equal, constant on top of constant. So it is set up for elimination. My C coefficients are 3 and 8, not the same number. My A coefficients are 9 and 5, not the same number, okay? So let's look at our C's, okay? Can I multiply 3 by anything to make it an 8? Not a whole number, right? Okay. Can I multiply 5 by anything to make it a 9? No. That's why you're going to have to multiply both equations. Okay? So there's not really an easier one to get rid of first here. Okay? Because 8's not divisible by 3, 9's not divisible by 5. So I'm going to have to multiply both equations by something to get the variables to be, to get the coefficients to be the same number. So you really just got to pick. Do we want to get rid of C or A? C, okay. So my C coefficients are 3 and 8. So I need to figure out a multiple. I need to figure out my least common multiple of 3 and 8. The easiest way to do this is to take the big number, 8. Well, we already said 8's not divisible by 3, so we can't make them 8. What's your next multiple of 8? 16. Is 16 divisible by 3? Nope, can't make it 16. What's your next multiple of 8? 24. Is 24 divisible by 3? Okay, so my goal is to make both of the coefficients 24. Okay? What do you multiply 3 by to make it a 24? 8. What do you multiply the 8 by to make it a 24? 3. Now, if I do that, both of them are going to be 24C, which is part good, but not fully good. Okay? What else do I need them to be? One of them needs to be a negative. Does it matter which one I make a negative? Makes no difference. Y'all want to make the 8 or the 3? 8. Okay. Again, it matters none. What's negative 8 times 3C? Negative 24C. What's negative 8 times 9A? What's negative 8 times 75? Now I need to multiply the bottom equation. What's 3 times 8C? What's 3 times 5C? Sorry, A. I don't know why I said C. 15A. And then what's 3 times 67? Now, do I have a variable that has the same coefficient but opposite signs? Yeah, my C's have 24 coefficients. One's positive, one's negative. So now it's going to eliminate. Negative 24 plus 24, gone. Negative 72 plus 15, Negative 57A. Negative 600 plus 201. Negative 499. What am I going to do next? Divide both sides by negative 57. And we get A equals it's negative 499 divided by negative 57. We have calculators. Yes, ma'am. That's what I get just for listening. Negative, negative? Positive 7. Thank you for catching my mistake. It doesn't matter which equation you use to plug it back in, just use one of the original equations. Don't use one of these that we had changed it to. Use one of the original. Do y'all want to use top or bottom? Bottom I heard first, we'll do bottom. So 8C plus 5 times A, which we just found to be 7, equals 67. So 8C, what's 5 times 7? Equals 67. What do I do next? Minus 35 on both sides, so I get 8C equals 32. Then I divide by 8, and we get C equals 4. Guys, just using your knowledge of what you know about life. Does it make sense that my adult tickets cost more than my child tickets? Yes, normally children are less expensive than adults. Okay? So if I got something like 7 for adults and then like 40 for children, I would just, knowing what I know about life, I would go back and kind of check. Okay? So my answer is adult tickets cost $7 and children tickets cost $4. Good? Okay, before you start on your homework, I'm going to show you something